In this segment, we are going to look at the graph and comparisons among different springs. So in the real world, what we have here is we can see there's three different cases that I've put together here for us. In all three cases, the spring has been stretched 1 meter. And you can see that whether I'm stretching or compressing it, it took 3 newtons to stretch this 1 meter. It took 6 newtons to stretch this 1 meter and 9 newtons to stretch this 1 meter. So what we can see then is that this is a weak spring, this is a strong spring, and this one is intermediate, meaning it took less force to stretch at the same distance, the greatest amount of force to stretch at the same distance, and an intermediate force to stretch at the same distance. So what I did here is I stretched it a variety of distances for each of the 3 springs, and we have the force data for the 3 different springs. And what you may notice then is it produced 3 different lines. And the most notable feature of those 3 different lines is they have 3 different slopes. Y equals 3x, y equals 6x, y equals 9x. So this is y equals 9x, the strong spring. This is y equals 6x, the intermediate spring. And this is y equals 3x, the weak spring. And if you recall, Hooke's law is F equals K delta X. And K, the spring constant, is the slope. 3, 6, 9. Weak, intermediate, strong. And that strong represents as a steep slope. Now this is where we also want to talk about the meaning of the spring constant a little bit more in depth. Well, if we rearrange this equation and solve for the spring constant, we get the spring constant is the force applied divided by the displacement. And it has units of newtons per meter. So if we have a number that comes out of this, say 6, that is 6 newtons per meter. But what we lose sight of is that it's 6 newtons per 1 meter. We don't generally write the 1. So if we have a spring constant of 6 newtons per meter, what that means is we stretch the spring 1 meter. It is the force required to stretch the spring 1 meter, 6 newtons. 3 is the number of newtons, or the force required to stretch it 1 meter, and 9 is the force required to stretch it 1 meter. So the spring constant K is the force required to stretch or compress a spring by 1 meter. It is the slope of an delta x F applied graph.